which is the servo motor and motor controller integration dual motor control using potentiometer with ArduinoNano. It's a direct port manipulation. Its objective is to control both a servo motor and a geared motor simultaneously using analog input from potentiometers, utilizing direct port manipulation without using a standard setup and loop functions. So here is my material that I use for requirements for this experiment. I'm using a ArduinoNano here, a USB cable for the Arduino, and a potentiometer, a breadboard, its jumper wires, a servo motor, a geared motor, a motor controller, and a step up. And I'm also using a 5 volts supply for the geared motor. In this experiment, in the introduction, a servo motor controlled directly via PWM from Arduino. Its position control from 0 degrees to 180 degrees. Geared DC motor controlled via TB6612FNG motor controller. In the potentiometer, the code utilizes bit manipulation for direct hardware control, timer for servo PWM generation, timer for DC motor PWM, and ADC for an analog reading. In the pin connection table, the potentiometer is connected to the ground, 5 volts, and analog 0. The servo motor is D9, power for 5 volts, ground for the common ground, and the motor controller is connected to the Arduino 5 volts, ground, external supply, D10, D8, 7, 6, and DC motor plus and negative, and the geared DC motor. The important is all ground connections from this Arduino servo power supply and the motor controller and DC motor power supply must be connected together. The servo and DC motor should have separate external power supplies. Do not power any motor from Arduino's 5 volts pin, and the TB6612FNG serves as the motor controller for DC motor only. And the software setup is basically from Arduino website, launch Arduino. So this is just a basic setup, and we all know how to use it. And here is my screenshot code. You can also see my code here. Here it is, the code, the ADC functions, main program, the enable motor driver, the main loop where the servo control and the motor control for forward and reverse, and also there is a stop speed. For the procedure, connect the hardware and assemble the circuit as described in the hardware setup. So here is my hardware. I I already set up my hardware and open the Arduino IDE, launch in the Arduino IDE. So here is my Arduino. I already have my code. Copy the code, select board and port, upload the code, power the supply, and observe the result. So let me demo that later. The mapping should be in the potentiometer, the servo angle, potentiometer, the DC speed, and its direction. For the code explanation, AVR.io.h provides definitions for AVR microcontroller registers. The AVR interrupt.h provides interrupt-related functions. Util.delay.h provides blocking delay functions. And its definition is here. In the main function, the ADC servo init initialize timer for direct servo, DC motor init initialize the motor controller and timer for DC motor, and LED indicates blinks that builds 3 times to indicate successful startup. In the main loop, here in my code, here is the main loop for the servo motor. And the DC motor. So in this code, it reads analog value from potentiometer. And here in ADC read, the DC motor pin reads analog value from potentiometer, and the map value is maps 0 to 1023 to 0 to 180 degrees for servo. And in the DC motor, as you can see, the LED indicate function blinks the built-in LED a specified number of times. Servo init function is initialize timer in fast PWM mode with ICR1 as stop to generate 50 Hz signal. Servo set angle converts an angle 0 to 180 degrees to corresponding PWM pulse width. DC motor function initialize the TB66 FNG motor controller by setting direction. Pins as output enables the controller and configuring time. DC motor set speed sets the PWM duty cycle for the DC motor using timer. The DC motor controls the direction forward in high, in 2 is low, in reverse, in 1 low, in 2 is high. ADC init function initialize the ADC with AVCC reference and scalar of 128. In expected result, as you rotate potentiometer, you should observe the servo motor moving to different angle position. The servo shaft should rotate smoothly from 0 degrees to 90 degrees, as the potentiometer is turned from fully counterclockwise to fully clockwise. And the servo position and DC motor speed direction should correspond directly to the position to the respective potentiometers. In troubleshooting, no serial output, incorrect LED behavior, no LED lighting up, and potentiometer not working. For the discussion, in bit manipulation, explain how bit manipulate is used to control the servo motor and DC motor directly. What are the advantages and disadvantages of this approach compared to using Arduino function like digital write and analog write? So in my discussion, I already have an answer, and my answer was bit manipulation directly sets or clears register bits for faster and smaller code. And its advantage, speed, memory efficiency. Disadvantage, less readable, non-portable, error-prone, and in Arduino functions like digital write are slower but safer and easier. Second is servo motor control. Why can a servo motor can be connected directly to the Arduino without an external motor controller? What internal components allow the servo to interpret the PWM signal and hold its position? So, a servo has a built-in motor controller, feedback potentiometer, and control IC. The IC decodes the PWM signal and drives the motor to hold the commanded position, no external driver needed. In the DC motor control, explain the purpose of the motor controller in this experiment. What are the functions of AAN1, AAN2, PWMA, and STDY pins? Why is an H bridge necessary for DC motor control? So, it controls DC motor direction and speed. Pins AIN1, AN2 sets direction, PWMA controls speed via PWM, STBY enables the chip, and the H bridge allows reversing motor polarity and braking. Number 4 is the ADC conversion. Describe the process of analog to digital conversion. What is the range of the ADC values in this experiment, and how does the Arduino convert the analog voltage from the potentiometer to a digital value? So, the ADC converts analog voltage to a digital number by comparing input to reference voltage corresponds to 0 to 5 volts in 0 to 1023. Arduino samples the voltage on an analog pin and scales. Value mapping is explain how potentiometer values are mapped to servo angles and DC motor speed direction. Why is dead zone implemented for the DC motor potentiometer? So what problem does this solve? In map path value 0, 1023 and 0180 converts a servo angle. For DC motor, the dead zone ignores small potentiometer movements near center. So this solves jitter, prevents the motor from oscillating when the pot is centered. Pot or put. BC wait delay. Explain the purpose of the delay. Function in the main loop. So what are the limitations? Here, the main loop. functions, what are the limitations of this type of blocking delay? What are the alternative methods for creating delays without blocking the microcontroller? And the delay milliseconds provides a stable loop timing and the bounce effect. Its limitation blocks all other code execution during the delay. The alternatives in milliseconds is non-blocking timing, timers with interrupts, or state machine loops. Lastly, explain how the main loop continuously reads both potentiometers and updates both motors. What would happen if the delay in the loop was removed or significantly increased? The loop continuously reads both puts and updates both motor each iteration. Without the delay, loop runs too fast, causing jitter, excessive current draw, and possible servo overload. With too long a delay, slow response, jerky motion, and loss of real-time control. So in conclusion, bit manipulation offers superior speed and memory efficiency for motor control but sacrifices code, clarity, and portability compared to standard Arduino functions. Servos integrate their own control electronics, enabling direct connection, while DC motor require an bridge like a motor controller for direction and speed control. For the proper loop timing is essential, and too fast causes jitter, too slow reduces responsiveness, and understanding these fundamentals enables efficient, real-time, embedded motor control. So here is the demonstration. We have a potentiometer, ArduinoNano, that is connected to the laptop, and a geared motor, a motor controller, a servo motor. As you can see, if we see, and then in reverse, how it works. And here we have a step up, and we have a connection from the or to the 5 volts, so that our geared motor will function. So here, let me turn it on. So that's how it works. In reverse, and that's it. In center, all stops. Forward, and reverse. That's it. Thank you.